Hey guys, Greaves here again. Hope you all are doing well. All right, so today, a couple things. Gonna send you a couple of links, obviously, one through YouTube, just for a demonstration, right? And then another kind of virtual lab, one of those applets. Just to let you know, the applet always works better, I find, right? If you're gonna use that one through Internet Explorer. Okay, I'll put a little note on that as well. Okay? All right, so what we need to talk about today is something called diffraction. Okay? Diffraction. What is diffraction? Okay, well, let's hold off on its definition for a second. Let's go over a couple things about waves. All right, so if something is a wave, right, what are some characteristics of a wave? Well, if you are a wave, right, you will reflect. What does that mean? All right, suppose you're going down this way. Right here's a wall, right? If this wave hits this wall, it is going to reflect, right? So we're going this way, hit the wall, and this other guy is going to come back, right? Right? So that's one characteristic of a wave. All waves, right, reflect when they hit boundaries. What's another thing that they do? Transmit, right? Remember, also, wave is just energy, right? So this energy, when it hits the wall, is going to come back. An echo, as an example, right? Transmission. Let's do it like this. Let's do a rope, right? And let's just have another heavy rope here, right? So I send, right, a wave down the rope, right? What's going to happen to this wave when it hits this rope? Well, we know that some of it's going to reflect back, but some of it also is going to, in fact, transmit, right? Let's continue this, right? Into the new medium. So, if you're a wave, you reflect and you transmit. What else does a wave do? Well, a wave will also be absorbed, right? What do I mean by that? Well, it's like friction. Think of like friction. Suppose I have an infinite, there's a rope, right? Infinitely long. And it's really what happens, right? I send this rope down, this wave down an infinite long rope, right? If I come all the way down here, the wave, yes, is going to travel, and there's no boundaries. It's free to move, right? Just always to the right. Well, what's going to happen here? Well, if this was 1 meter, well, this might be like 0.8, right? Way down here. 0.6, right, and so forth. Well, why is that? Well, just some of the energy, right, is being absorbed in the medium as it's traveling from right to left, or I should say, in this case, left to right. Just think of it like friction, right? Think about it if you're going to yell your friend, right, your name, right? You're outside and, hey, Johnny, right? They're far away. They might not hear you. Why is that? Because that wave is traveling through air, right, and it's just being absorbed as it goes through. Okay, so something interesting about if you are a wave, you diffract, right? So let's take a look at what diffraction, let's say we diffract, but I'm going to say diffraction. What is it? Okay, it is the bending of a wave. Now we just look at it really usually in physics through a small slit, right? Or let's just say around a barrier, right? A barrier. Okay, so let's take a look. So I had said before, I'd given you some examples of a wave. So here is, if I'm looking downward, I'm looking at a water, right? Put a pool of water. Throw a pebble into the water. What's going to happen, right? So I'm looking down, right? What's going to happen is, as you look down on the water, you're going to see these spherical waves, right, of the water, right, kind of radiate outward in all directions, right? So here are these waves propagating away from the source. And by the way, what do we call these, right? These are called wave fronts right here. We just use these, right, to give us a general, right, indication of the wavelength, right? So let's take a look. Now, let's just say this wasn't a pebble in the water. Let's say this is the sun, right? And the sun is obviously sending us waves, right? I'm actually, believe it or not, looking out my kitchen window, And, it's 2 o'clock in the afternoon, so light is coming through the window. Where did that light start from? Well, it started at the sun, very, very far away, right? And the sun is actually three-dimensional, right? So I'm just drawing these these circular waves, but it's really three-dimensional, isn't it? It's a sphere expanding outward in all directions. So look, you can see right here, it's very curved, right? But however, what happens to these waves as I get farther and farther away, right? Well, look at what's happening. Well, these wave fronts, by the way, these are still my wavelengths, right? Become, as I get farther and farther away from the source, they almost become parallel. They're not, right? But we can kind of estimate that they are parallel, right? Because they're so far away. The radius is so big that it's difficult really to detect the radius of curvature. Okay, so now let's take a look. I get these waves, right? They're starting at the sun, and they're traveling 93 million miles away. And let's go back to the case that I just said before. Here's my window, right? Here's the window. These are the walls, right? We're looking down, right, on the walls. Here's the window. And here come these waves from the sun. Here they come. So they're coming this way. Okay, and here's a little opening that these waves are allowed to go through. So what's going to happen? All right, let's make an imaginary line back here, an imaginary line back here. This wave right here, when it hits the wall, what is it going to do? Yeah, you guessed it. This whole section is going to reflect. This is all going to reflect. And yeah, you're right, some of it is going to go through, but we're going to ignore that for a second, right? But what about this part right here? All right, this part right here goes through this slit. And then what happens to it as it makes its way through, right? Well, it makes its way through, but does it get kind of cut off like this? Well, the answer is no, it doesn't. What happens is part of this wave, which is really weird, right? Just a characteristic of a wave, right? Part of this wave that comes through actually bends, right, around this opening, right? And we get this wave here. Let's extend that. See if I can draw this and make it look nice, right? And what happens is, as this wave makes it through, it actually spreads out or bends around the medium, right, or the opening, shall we say, right? If it didn't do this, believe it or not, when you're upstairs in your room, or if you're in a room, right, and you're talking, right, if there's an open door, someone in the other room is going to hear you, aren't they? Well, why is that? Because when that sound wave hits the open doorway, it diffracts through, right? So this is diffraction. It's the spreading of a wave, right, through a barrier or through a slit. So let's take a look at another example. This would be a small slit. And by the way, I'm not going to get too crazy with it, right? But as I make this slit smaller or bigger in frequency, I'll do this more tomorrow, right? The amount of bending varies. I'll give you that information tomorrow. Let's get the generals down today, okay? So here's another, right? This would be a slit, right? An opening. This is a barrier. This is free to move over here. So let's take a wave that looks like this, right? And let's just send it straight this way, just like I did before. Well, what's going to happen here? All right, there's my imaginary line. This wave is going to bounce back, right? This portion of the wave. But this one here is going to do what? Transmit through, right? And what's going to happen is, right, see if I can do the best job that I can, right? This part is going to bend around, right? So this phenomenon, right, is called diffraction. And by the way, if you are going to be a wave, you must diffract. Is that okay? Let's take a look over here for a second. What do I mean by if you're a wave? Hey, if I threw a baseball through here, when the baseball goes straight through, wouldn't it follow this path right here? The answer is yes. It's not going to go through and then, oh, I'm going to curl off in that direction. Not what happens with a baseball, right? But if you're a wave, yep, waves bend around slits and openings. Okay? All right. I will send you, take a look for some, I guess, YouTube videos, right, on maybe some better demonstrations, and also take a look for that applet, right? I'll give you some instructions. Just get to mess around like a virtual lab. All right? See you later, guys.